Hello students. So earlier we studied Euclid's division lemma. Now we'll study Euclid's division algorithm. So Euclid's division lemma is helpful in finding HCF of two or more numbers. So Euclid's division algorithm states that in order to find HCF of any two numbers, any two positive integers such that which are C and D, where C is greater than D, we use following steps to find the HCF of these two numbers. So first step involves applying division lemma on C and D such that C becomes D into Q plus R, and of course R is greater than equal to 0 but less than D. Now we have to check if R is 0 at this stage. If R is 0, then D is the HCF of C and D. If not, if R is not equal to 0, then we apply Euclid's lemma on remainder R and D. So D will be expressed as R into some number Q1 plus remainder, let's call it P. Again we'll check if the remainder is 0. If not, then we repeat these processes. So we'll apply Euclid's on R and P. Whenever the remainder becomes 0, the divisor at that stage would be the required HCF. So we all did long division method in earlier classes to find the HCF of two numbers. If we look closely, I'll take you through an example and we'll discuss how they both are related. So let's suppose we have to find HCF of two numbers 27 and 6. Yeah. So using the algorithm, first step would be to express 27 applying Euclid's division lemma on 27 and 6. So 27 would become 6Q plus R. So in order to find values of Q and R, we'll divide 27 by 6. So the quotient would be 4 in this case and remainder will be 3. So 27 becomes 6 multiplied by 4 plus 3. We check if the remainder is 0. It's not, the remainder is 3. So we apply, the second step would be applying Euclid's division lemma on 6 and 3. So 6 will be expressed as 3 multiplied by some number Q1 and P, or in order to find these values we'll divide 6 by 3. So the quotient is 2 and remainder is 0. So 6 will be expressed as 3 multiplied by 2 plus 0. Now we see that the remainder is 0 at this stage, hence the divisor, which is 3, would be the required HCF of 27 and 6. So HCF of 27 and 6 would be 3. Also 3 would also be the HCF of 6 and 3. which were the dividend and divisor at the stage where r was 0. Now let's see how we used to apply long division method in earlier classes. Taking the same set of numbers 27 and 6, so we divide 27 by 6. 4 would be our quotient and 3 would be remainder. Now what we used to do was, when the remainder was not 0, we would make this 6, which was divisor in the first step, we would make it as dividend, and the remainder will become the divisor. So again we'll apply this. Now at this stage remainder is 0 and the divisor, which is 3, would be the HCF of 6 and 27. So essentially we've seen that the Euclid's division algorithm is nothing but the long division method that we used to apply earlier. So now we have to find, the problem is that we have to find HCF of let's say 210 and 45, right? So what would be our first step? We have to first see that 210 is greater than 45, so C is 210 and D is 45. Applying lemma, C would be expressed as DQ plus R, or (45) multiplied by some number Q plus remainder R. In order to find values of Q and R, we'll divide 210 by 45. So I see 45 multiplied by 4 is 180 and 45 multiplied by 5 is 225, which is greater than 210. So 45 multiplied by 4, 180, 30 would be the remainder. So 210 becomes 45 multiplied by 4 plus a remainder of 30. Now we have to check if remainder is 0. We see that actually 30 is not equal to 0. So now we'll apply Euclid's division lemma on 30 and 45. Next step is apply division lemma on 45 and 30. So 45 is greater than 30, so we'll express 45 in terms of 30. So 45 would be written as 30 multiplied by some number Q plus a remainder R. Again, in order to find these values, we'll divide 45 by 30. So 15 is the remainder now. So 45 would be written as 30 multiplied by 1 plus 15. Again, remainder is not equal to 0. Now we'll apply division lemma on 15 and 30. So 30 would be written as 15 multiplied by a number Q plus some remainder R. So in order to find these values, we'll divide 30 by 15. We see that now the remainder is 0. So now the remainder is 0. The divisor, which is 15 in this case, would be the HCF of 210 and 45, right? So we'll write HCF of 210 and 45 is 15, which was the divisor at the stage when remainder was 0.